back at it again here, checking out this unit. It's a 100% outside air chill water unit, and with the chill water coil and a gas furnace. And they had some issues with it the other day, and we're just checking a few things here and see if we can figure out what was going on for them. But what happened was they called me and told me to pick them up a new motor. The motor had burned up. So I got a new motor, brought it in, popped it in, and come to find out, when I turned the unit on, they had some other issues. This motor, when it caught fire, or when it burned up and started smoking, the fire alarm went off. So anyhow, started checking it out after I got the motor in. I noticed that this room here was filling up with quite a bit of positive air pressure. So checked it out and found that these fire access dampers here were open. Fire damper panels were open. So as I was checking things out here, I noticed that there's two fire dampers up here, and both of those fire dampers were completely closed. The fuse link, which I have somewhere down here, was completely broken on it. And that's at 165 degrees, so it had to get pretty hot in this supply plenum for those fuses to open up. So right now I got the motor running, and I got the heater jumped out, and we're gonna check this heat real quick here and see what's going on, because technically there's a high limit on this, and that high limit should have picked this up before that became the case over there and tripped that. I don't like how that's really getting up in that high of a range there, but let's see. If it starts getting up above 100, yeah, I need to take a look at that and see what's going on here. So yeah, we're at 100, 100.3, 100.4. Yeah, I definitely need to see what's going on with this unit here. It looked like it just keeps on kind of climbing there, so let's see if it gets up again. There. Yeah, that's pretty hot. 101. Let's see what's going on, because I think the chill water valve is open as well too. So anyhow, yeah, I might have moved those there, but let's go on this air handler here and see what we got going on here. So right now it's in a call for heat. Let's lower that, see if anything turns off or does anything there. Lower it all the way down, see what it does there. See, I shouldn't have the discharge temperature getting up that high anyways. Something's going on with this unit here, and there's no way that this thing should be in high heat at the moment there, but I don't know if you guys can see that there, but yeah, it's kind of hard to tell, but I do got some fire inside of there. That red light blinking is my camera. So but yeah, we need to figure this thing out. There goes your high limit right there, and that opens at 180. Yeah, it's kind of set pretty dang high. That's me. Because those fusible links trip off at 1. So let's pull this jumper off, because right now I got the heat call jumped out, but like I said, it shouldn't be getting that hot. Wonder if something's going on with this board here. I know there's a way you could kind of test this thing out, and I think we're gonna have to do that, or it could be the discharge air sensor, which I want to say it's gonna be these two right here. They might need to even be calibrated, but let's take a look here, and let me get set up here, and then I'll let you guys see what I got going on. All right guys, so I think I know what's going on here. Kind of a weird issue here, but anyhow, so as you guys can see right now, I am reading, I don't remember which one was my, yeah, that's my light there, 0.2 volts DC. Okay, so this is your DJM controller. It does your heat and everything else on here. This is going to be your I can't remember which one was your sensor here, but anyways, one of those is going to be your supply air sensor and all that. So right here where I got these test ports, you can see you got these three little triangle kind of deal ports, And so you have your supply set point, so which is going to be this one here, and then here's your discharge temperature sensor, and this is your common. So normally what you should be able to do is put your meter on common, put your lead on supply air or discharge air sensor, and then you have a discharge sensor calibration right there on that rotary little switch right there. So anyways, I'm looking here on my phone and I can show you guys here what they should be at. So if you see here, I got measurements are made in volts DC. 1 volt DC equals 10 degrees Celsius. So right now what's weird is we're reading 0.1 volt DC, which is saying this air is freaking freezing cold, because 1 volt is 50 degrees. So that's not reading right. But here's the other kicker though. So let's look and see if this is controlling properly here, right? So we should be able to go here. We should be able to set this thing down to 68 degrees. According to here, you can see 68 degrees is 2 volts DC right there, and I'm getting 0.1 as well, 0.2 volts. So let's go to the calibration here, and let's try to adjust that. So I'm there, so I'm adjusting it right there on that. As you guys can see, it's the discharge supply calibration, and I still have the same thing. So let's go all the way back, and I still have the same thing. So I think something's going on with this DJM here. I do notice a little, I'm not sure if you guys can see it, but it's got kind of like some little burn marks back there. But anyhow, let's open this thing up and see what we find going on. But I think something's going on with this DJM controller, because it's not even reading that. So the problem is that I have my discharge air sensor or set point set to something, and it's overshooting it. Well, eventually it's going to get too hot in there, and it's going to trip this unit down or do what it did. So so that is an issue. This unit here, here's another, I guess, description on that controller there. But this is a engineered air unit. Pretty simple unit. It's not too difficult to work on. It looks like there are a lot of things in here, but in reality there's not. So this is going to be your start stop from automation there. This one here is going to be your heat enable from automation as well. So all I did earlier was I just shorted out that sensor here on the wires on the terminal block board. But anyways, to get the heater to run, power comes in, goes through your fuses. You have your blower contactor, and then you have your heating contactors here for your preheat contactors here. You got SSRs right here for your heaters. This is all preheat. So what you have here is 100% outside air comes into this unit. As it's going through this unit, for example, if it's cold outside or whatever, that outside air is going to get preheated. After it goes through the preheat, then it's going to go up the unit, and it's going to go through the furnace. They're using the furnace for heat, as well as reheat for humidity controls and things like that as well too. Then you have your chill water coil over there as well. But anyhow, this is your preheat controller here. So pretty much if that outside air is, for example, let's say, I don't know, above or below, let's do this right here, 110 degrees, this here is gonna allow your outside air, your preheat to come on here. So let's take a look at the amp draws on the preheaters right now. Okay, so they're coming from here. So right now we're in preheat. As you guys can see, it's got 19.16 amps or whatever there. So let's drop down this controller here. We're gonna lower it. Let's see if we still get some preheat. Here, let's see what's going on there. Shouldn't be in preheat there, but let's look at these other wires here. Yeah, that should. actually start coming down. Something's going on with this preheat too. From what I recall, that's the only controller there for preheat. So let's take a look at this. Yeah, see that SCR controller there. Should control the SSRs, and then your Johnson. And we got, that's not us though. That's they're actually testing the fire alarm system here. So let me get back to you guys here. All right, guys. Well, sorry about that. They're testing their fire alarm system out here today. So the fire alarm company had set off the alarm for this building that I'm working in, coincidentally. So anyhow, we're back at it again. So while the alarm was off, I went ahead and said, you know, I couldn't run the unit. The unit was in fire alarm. All the smoke dampers were closed. So I said, man, I mean, I was pretty confident there's something going on with this controller here. So I went ahead and pulled it out. The customer had a spare on site, and as you guys can see, I wired it all in. It's got a heat call right now because of the discharge air temp set point, but now we're doing the same thing here, and we're actually reading 2.2 now. So if I grab my phone out, let's see if I still have that manual there. Bear with me, guys. Let me pull it back up here. DJM 3.4. Alright, so let's go back to where we were here. Okay, so according to this, it's reading 2.2. So let's, or 3 volts DC right now. We're reading 3 volts DC. And 3 volts is corresponding with 86 degrees Fahrenheit. We are sitting, here, I forgot to flip this dip switch up here. Okay. So anyhow, we are sitting at about, let's knock this down here. So we got our Fahrenheit here. Let's go to 68 degrees Fahrenheit. Let's see if that's on the list there. It'd be easier to do it this way. Okay, so 68 degrees Fahrenheit should be 2 volts DC. Right now we're running 3 volts DC. Let me drop this down. See, so I dropped it down right there, and my voltage starts to drop. So I need to calibrate this because this is incorrect. So we're gonna go to 68 degrees right there. It's reading 3 volts DC. We need that to read 2 volts DC. So we're gonna go over here to the calibration terminal or switch, and we're gonna raise it or turn it clockwise till we get 2 volts on there. About as low as it'll go. There's 2.5. That could be a little bit of discrepancy in my meter too though, but 68, 2.5. I got it as low as it would go. Oh, you know what I need to do? I probably need to pull this knob off here. That's probably what I really need to do, because I need to be sitting technically right there at 68 is ideal. So anyhow, let's see how we get this knob off here. Try to do this with one hand. Alright, that. Alright, so let's get that knob off. We're gonna set this bad boy here to 2 degrees or 2 volts DC. Okay, we're at 2 volts DC right there. So we're gonna put this knob back on at 68. So we'll make sure we don't move it too much. Here. Okay. Sorry guys, I'm trying to do this with one hand here, so bear with me. So okay, so now we're at 2 degrees. I mean 2 volts DC, 68 degrees. So let's look at our deal here, and we got at 3 volts DC is 86 degrees. So you got 86 right there. So we're gonna go to 86, and we should have pretty close to that 3 volts DC. Might be a little hair bit off right there. See if that changes that 1 volt. So let's do a hair bit right there. Let's see if we get that change on there. There you go. Okay, perfect. So we are where we need to be right there, about 86, 87, give or take. So I'm not really too, you know, it doesn't have to be perfect, but let's go back to 68 here, and we're back at 2 volts. So okay, I'm happy with that. So now we're going to check discharge air temperature here, see what we're reading there. So well, all right, finally we're reading something. So we got 1.6 volts. 1.6 volts corresponds to hair bit over 59 degrees. So let's just call it 60 degrees. We need to see what the actual supply air temperature is on this unit here, which I got my probe all the way up there. There's really nowhere else to put it, so let's go up there right quick. Up here right quick. Alright, let's see what we got here. So we're doing a little cooler than that. We're at 54.9. Let's see if that changes at all. I think that should kind of stick around that spot right there. So all right, 54.9 is where we're at. So let me grab my thermometer. I think I'm done with that here. All right, let's go back over here. 54.9, so let's call it 55 here. So if we're at 55, we should technically be at a hair bit under 1.5, so probably about like 1.3, I would say, just to keep it close. So we're at 1.6 actually. So we're a hair bit over, according to this, we're a hair bit over 59. So we need to drop it down about 5 degrees. So we're gonna go up here. Let's see if it's raising it. We need to drop it. Come on, hair a bit more. There you go. All right, I call that good. We're at 1.3 there. Now on our discharge air, it's reading a hair bit under 55. So now we're gonna try this again. We're gonna jump out the heat because, like I said, their automation system is down right now, so they're not getting calls for heat anyway. So right now this isn't a heat call because of that supply air temperature set point there. So so yeah, that's why it's in that heat call as well. So anyhow, we're gonna do that, go from there, and see what we get here. But right now this thing is set to 2 degrees. Let's see what happens if we lower it and raise it. I mean to 68. So yeah, let's drop it, let's raise it, and that's where we're at. So you know, I kind of messed up right here. Let's do something here a little different, because I can see the dial is not really going under and it's going over. I don't really, that knob is. So let's try to recalibrate this thing again here and see if we can get it right. Okay, technically that's probably about where it should be there. So let's adjust that. Okay, and then we're going to go to 68. All right, and then let's lower this. going up though. Okay, hold on here. I think I have to turn this off. Yes, that's the problem there. Yeah, so you actually have to turn that dip switch off when you do it, and then you can set it back. So right now we're reading correctly. If I was to go to 77, I got 2.3, 2.4, probably gonna stop at about 2.5, let's call it. 77 is 2.5. So let's go right there. That kind of gets it right there. Should be going to 2.5. Come on. Yep, there we go. So we're just a hair bit over like earlier, but it's not going to be 100% accurate since we're using this little rotary deal. But yeah, see, it's kind of past that 95 mark too, so it really should stick there. Not really past that, but anyhow, at 50, we're at pretty much 1 degree. I mean 1 volt DC, which 50 is 1 volt DC. So all right, looks like we're doing pretty good. So let's put this thing back to normal. We're at 2, we're at 68. Put that thing back to normal. I don't care what that goes to right now. It's calibrated. So anyhow, so now let's drop this thing, see what it does. Problem is 50. Just curious if it loses that heat call. It might not. Yeah, let's go ahead and see what all these other switches were set to. So you got that bottom one there was set to S, so that's the same thing there. Top one there was set to that little dial there. Yeah, that's the same. That one there was set to S there, and then that one there is set to B. Just set the B there. Not worried about those two. There's some back there that's set to S. It looks like B, and S. So okay, so everything is set to pretty much the same there. Just wanted to make sure. Now the other thing we got to look at is what's going on with this preheat. This preheat should not be running right now, and it is not running right now. Okay, so all right, so let's do this then. So we're gonna adjust this. Let's see what happens with that preheat. So my contactors are pulled in. Yes, they are. So what are you doing? Should come on now. Yeah, okay, that's running at 28 amps. That one's not. That one is. That one is. Okay, we're gonna have to check and see what's going on with this preheat, because honestly, if I have this set down this low, I mean, this is negative 30 degrees. I mean, that, or yeah, about negative 30. That should not be coming on. I understand it coming on there, but I wonder if something's going on with the thermistor for this here, the preheat sensor. But anyhow, would really like to get this thing checked out too. Not sure which one is the sensor. I think this is it here. It comes out, goes over here, goes up, and it comes over here. So this is your preheat sensor right here. Yeah, and this is your high limit for your preheat. So anyhow, feel a little bit of air in there. Let's see if I can get this thermometer, stick it in there, see what that temperature is on that sensor there. But that should be reading, I think this is before. So this is your outside temperature right now, 75 degrees, so 76 degrees. So that preheat should not be running right now. Why is it pulling current? That is gonna be news to me. I'm not sure why it's doing anything there, but at the moment, this leg here doesn't want to really. I can't really get my meter on there, man. That's why I'm not reading any type of current on there. Let's see. Oh, yeah, still 4 volts there. If I raise it up, that's when it should start pulling some current. See, I'm sending 10 volts DC to that controller, which then sends it to the SSR. So and this is set to DC there. Let's take a quick peek there. So it is set 1, 2, 3, and then the last one. All right, guys, so back at it again here. Sorry about that. Yesterday the customer came in and kind of showed them what I found, and got it all up and running right except for the preheat. Told him I'll come back today to look at this preheat here. So I didn't get to really finish filming yesterday, but anyways, I kind of want to leave off where I finished yesterday. Start off where I finished yesterday. And so they had a bad DJM controller. This controller wasn't reading right, as you guys saw there. So I got that going. So now I came back to look at this preheat issue. It's a little cooler today. Let's see what that temperature is here. Well, I guess it's not that much cooler. It feels a lot cooler than that. Hold on here. Let's take a look at something. Maybe I'm not really getting in there. Let's look inside of here. See if I can get up in there. Yeah, I think I'm more inside the panel, in the middle of the panel there, the way it feels like. But let's see if I can get this probe all the way in there. Yeah, it's kind of hard to get it in there. All right, let's take a look at it here. Let's see what we're running at. So it's starting to drop. It's probably about like good 40-50 degrees outside right now. So let's let that kind of drop a little bit. So right now I got this set down to 10 degrees. So obviously let's set it up. All right, so there it starts calling for it. A little lower than 50 something degrees, about a little lower than 70 degrees or so. It starts calling for it. We're at 62, 60, yeah, it's in the 50s. Probably 61. Let's call it about 55 degrees or so. This might be a little off here too, but okay, so it should definitely be running all the way now. However, I disconnected this here. If I connect that, as you guys can hear it, it activates this relay, which activates the preheat contactor, which is what we don't want. So I'm gonna take a look at that and see what in the world is going on here. I have a feeling it's gonna be a bad D35 controller, because that wire that I disconnected is the yeah, so right up there, so right here you have this red wire here. We follow that wire, it goes down and comes out of your controller, and that is going to be that wire V, or that plus, I'm sorry, the V on the controller there, and it's going to be that little plus symbol on that, on the there's V on the Johnson controller, and it's the plus symbol right there on the D35. So I'm gonna pull that wire off and let's see what it does. Here, I'm gonna pull that wire off. Okay, good deal. So that actually shut the unit down, just to make sure. See, that's on W. I noticed these are your DC outputs to your relay. This is your SSR outputs. So then you have 24 volts, you have your ground. You don't have a wire for it yet. So this is acting funny here. See right there, I should be getting some sort of power going out to it, but let's see here. Yes, that's right. Yeah. So let's look at this preheat again. See, that should turn off. When I go all the way down like this, that should turn it off. I don't know what that signal voltage is here, so we're about to figure out. Let's open up this Johnson controller. control here, and we're gonna figure out what that signal voltage is. So give me a second, let me grab my tools and figure out what that should be there. Yeah, okay, sounds good. I'll get back to you guys. All right guys, so I got that cover disconnected here, and here's what I found so far. Just checked real quick, but I'm gonna let you guys know. Here's your thermistor. It was connected, and check the resistance value on it. That is on one hand here, but so we got about, sitting at about 900 ohms or so, which I looked at the PT chart. All it is a 10k ohm sensor. Looks like somebody might have replaced it recently, well, I don't know when, but this bag was in here, and that number there matches that number there. So they did replace the right sensor with the right one. It's reading the correct resistance value, about 900 and something ohms, equals 58 degrees. I think I read 57 degrees is when I checked it up. But anyhow, so the sensor's working right. But what I did notice is that we were getting 8 volts DC output on this wire here. So something's going on there. The controller wants it to go down. It doesn't want 8 volts DC. So as you can see here, you got your little LED light, and it will start at 2, 4, 6, 8, and 10. And we're really running 8 volts DC output, but this controller should not be outputting anything when I have it turned down that low. So I'm gonna condemn this controller here. I'm gonna see if they got another one. Before I do that, let me connect this all back up here, and I'm gonna play with some of these dials and see what we can get going on here. I'll get right back to you. All right guys, so I got it all wired back up again here. Unit's running right now, got it all wired up. So we're gonna take a look at the DC output on this controller here. Okay, and as you guys can see, I got 8 volts DC. I really shouldn't have anything right now there. So I'm gonna play with some of these dials here and just see what it does. Let me look at the book right quick. I know it's not that throttle valve, and that main output valve, minimum output valve, is at 0. So like I said, there's no reason why we should have what we have here. So even if I was to raise that up, let's say, and increase it, see that's the minimum there. So now I got the minimum at 2 volts DC. It's still outputting 8, I think, here. See, it won't do anything below 8 until I get, if I raise this thing all the way up, let's try this with one hand here. Almost there. Alright, there. I got 10 now, and I raised it all the way up. That's with the minimum barely sat there as well too. So like I said, if I lower this, let's see if I raise it all the way up, let's see what it does there. See, that's just, yeah, because I raised it all the way up. So I got this all the way down, and it's sitting at probably about 6 volts minimum. But anyhow, that should be 0. So I need to figure out what that little dial is right next to it, and see if there's maybe a way you can calibrate this thing here. So let's take a quick peek at it. And pull it up again on my phone here. Oh, this is a A350P. PS-2, I think. Oh, PS-1. Alrighty. So let's see what that little itty bitty dial there that looks like you shouldn't touch it kind of deal. Let's see what that. It really doesn't show me anything here. So sensor calibration. Oh, sensor connection. No. is set up for reverse acting, which is good. So you have the dip switches on here, but that's not gonna really help me there. That's more just like on recovery and things like that. So yeah, it doesn't show me, but let's go ahead and try it. I mean, it's bad anyway, so go ahead and just try to adjust this little dial right here. So remember where it's at. So let's see, it was here. Let's go that. No, usually it was here. Let's go that way. Okay, now let's take a quick peek. Might not do anything, it might do something. Nope, same thing. Yeah, we're just gonna have to get rid of this controller here. Something's going on with this controller, so let me call them and see if they have a spare one. If not, I'll just have to go pick one up. So yeah, same thing here. So anyhow, I'll get back to you guys here in just a little bit. Alright guys, so the customer didn't have a controller, so I had one extra in my truck here, so it's the exact same one, that A350 PS1, and that's a A350-PS1. So I'm gonna go ahead and swap it out real quick here and get back to you guys and see what else is going on with this thing, and hopefully everything works good after. Alright guys, so we're back at it again. I got that new controller installed. Just turned the unit on, it just started up. I got this set all the way down. I got the dip switches set the exact same. Actually, I forgot to set this one. This throttle here was set to 5, I think. Yeah, 5. So I set that to 5. So anyhow, that's all set up. I see the D35 is not lit, so that's a good sign there. So let's see what we're getting as far as DC goes. And the output now. Alright, so I got 0 volts. So we're going to turn this thing up. Let's at least register something on here. I'll try to dial it in so it doesn't shoot the... Okay, let's shot the 10 there. Yeah, see, I think that's because of the, that's probably because that's about like 9 volts or so. So, yep, and we got 9 volts there. That throttle range might be what you need to adjust that. Because if I go a hair bit, okay, so that's 1, 2, 3, 4. So 4 volts right there. So that's good. 4 volts. Yep. So we're doing pretty good now. I like this. So we're working on the preheat here. See, whenever it gets into that higher in that 10 range, what it's going to do is that D35, see right there, you're good, you're blinking. That red light is actually flashing there. So let's say I go to the higher range, it's going to stay steady. It's going to kick on this relay, which is going to activate the other contactor for the pretty much 3rd stage heat there. That's what it's going to be. So let's see if we're getting any amp draws on this one here. So right now we got 34, so we're just going to drop this just a hair bit. It's kind of slow. Okay, oh, not too much. It's real sensitive, but anyhow. So now our contactor turned off, but our D35 is flashing, so the preheat is running with the SSR. And we are pulling, as you guys can see, we're pulling current through the SSRs here, so they're doing what they're supposed to be doing. I think that's for that 3rd stage heater there. And same thing here. Yeah. So anyhow, looks like we're working pretty good now. Get some current right there. Yeah. So sounds good. It looks like it's doing what it's supposed to do. Right now we're sending a steady 1, 2, 3, 4, 5, 6 volts DC. So let's take a quick peek. Let's see if we're getting 6. Yeah, 6.9, so almost 7. So each one of these LEDs is 1 volt DC. It's got 10 LEDs on there for 10 volts DC. So I'm gonna try to kind of clean this up a little bit here. Got put some wire ties on there, clean it all up, and go from there. Let's look at that current on that new motor here. See what we're pulling, 19.7, 19.8 amps, like 20 amps, and it is rated at, over here, where's that motor at? 22.5 amps, and that's exactly what the data tag says on the motor as well too. Hear that chill water valve opening up as well. Well, let's go ahead and turn this unit off here right quick. I'll show you guys here what I did. So this motor has no drive on it. There's your motor here. There's really nothing to it. I put in that new motor here the other day, and so I'm gonna just start from the beginning again. Customer called out and said that their motor is burned up and they needed a new motor, so he sent me the data tag on that motor. Came in, brought them the new motor, and swapped it. And like I said, when I came in here, it did smell like something burned up. I should have at that moment checked that motor, but either way I did after anyways, and the motor was bad, so it did make out bad. But you know, just as good practice, even if they tell you and you smell it, just double check, because it could have been something else as well too. But anyhow, I swapped out the motor, turned it on, and like I said, I noticed this room here, this is 100% outside air with the ducted outside air coming in right there. So when I turned this unit on, I felt a real heavy positive pressure in here, and there's some spider webs in the corner. They all started kind of moving around. That's the carbon monoxide alarm that they got in here. That's probably got a little battery in it. But anyhow, so I went ahead, shut it back off. I looked at first I went to the supply grill because I didn't feel any airflow coming out of those supply grills. So I went to the supply grill outside here in their hallway, and I looked inside of there. There was a smoke damper, and smoke damper was open, so that wasn't the issue there. So then I came in here, I went in the supply plenum over there on the other side where I showed you guys, and I saw that the two dampers, or the two access panels, were completely off. So they weren't blown off, but somebody took them off and put them right there on the side. So anyhow, I looked in there and I saw that the fire damper was closed. So I had to put in larger access panels because there was no way I was gonna fit inside those access panels there. Let me show you guys right quick. So these are the original access panels. I have one here and one here, but that fire damper is way up there and way up here. And I'm sorry, but I can't fit through this 12 by 12 access panel. There's no way. So I went ahead and installed two new access panels down here, 18 by 18s. I was able to get in there, reset the fire damper, put in the new fusible links on both of them, and turned it on. After turning it on, I noticed that the supply air temp started shooting up, and then that's when I went to that DJM controller, figured that out. So now everything cycles on and off good. So give me a second, I'm gonna turn this unit back on and we're gonna just test the heat again one more time. I have to jump it out because they're having issues with their automation system, so I'm gonna have to jump out the heat and just make sure that this heater comes on pretty good and turns on and off as needed. So let me do that real quick, and I'll get back to you guys here in a second. All right guys, so the unit's running right now, just came on. I need to put this cover back on here as well too. I'm gonna put the new cover. This controller here. And I do have the heat jumped out, but it is not running because the DJM is not getting a heat call because I have the set point a little too high there, so or too low. So anyhow, let me set this to 40. That's where they want it at, 40 degrees. So like I said, if I go above, let's see, where does it start at? It'll probably start kicking in here any second. Here, somewhere around there. Yeah, there it goes. Okay. Anyways, we're gonna keep that at 40. So we're gonna go here to the DJM. We're gonna raise this up a hair bit. So I do have the heater jumped out right here, so I can hear the furnace starting to kick on now. So this unit needs this to call as well as automation, but this relay here is automation and is the start stop for the furnace, and it is not work. Their automation is having issues right now that they're working on. So anyhow, let's give this a second here. Watch what it does. I'm pulling 20 amps on the blower. I'm not sure if they're getting a milliamp signal or a DC signal on here, but let's go ahead and double check. 3 volts DC. So this right here is going to be their automation reset. So I gotta look at the book and see exactly how that is all set up there, but it has something to do with the reset ratio and all that good stuff there as well too. So let's see if that furnace kicked on. Takes a little minute here to start up, so let me give it a second here and see if it starts firing up. We got that Maxitrol modulating valve, so let's give that a minute here and let this thing start up. I'll show you guys what else I found going on over here that needs to be looked at. But well, while we wait on that, this is your high limit here. So in case you're wondering why didn't the high limit turn off the unit here, let me get my flashlight to prevent that high temp. Well, that high limit is set to 180 degrees. That's from the factory at 180 degrees. Well, the actual fusible links and the fire damper trips at 165 degrees. So yeah, this high limit's it's pretty much pointless at that point, because if it does get that hot in here, it's going to trip the fire damper before it trips the actual high limit. So it just takes a minute here, kind of start modulating in there, and so I can start seeing a little bit of flame. Here's, let me take a quick peek. Yeah, okay, I can see the flame. I'm not sure if you guys can, but it's kind of really hard to tell in there. Yeah, it's really hard to see it in there like that, but I do see it glowing blue in there. So let me see if I put a light on it, you're just gonna see the inside there, but I can see it glowing blue out there in the back there. So yeah, we're good. So anyhow, I wonder if that's adjustable. Let's take a look and see if this is even adjustable. Yeah, I think it is actually. Fan limit. I'll have to play with that and see. Let's see if I can get that adjusted there as well. But anyhow, we're heating. So we got a heat call. So now we're gonna lower this. When I did this yesterday, it didn't do anything, but let's see if we can lower it and lose that heat call. So we're just gonna give it a minute. Let's just go ahead and lower it to where it was earlier, where it didn't want to kick on there. So and let's see what happens here. It's gonna probably slow the speed down on the burner first, and then it will kick off if it needs to. So let's see what happens here. Let's give it a minute. Yeah, it takes a little while, so let's just go all the way down, see what it does. There it goes. Okay, so it kicked off, so it's doing what it's supposed to do. Turn it on and off as needed. So let's go back up. It's going into its ignition. Since the combustion blower was still running, doesn't need to do pre-purge or anything like that, just goes into ignition. And let's let it run for a little while on the lower supply, or where they want it set at, which is going to be right about there. Let's let it run there and see what it does. See if it kicks off here in a little bit. Other than that, guys, doing pretty good. So I'm gonna try to adjust that high limit and see if I could drop it down. If not, then I'm gonna recommend them replacing that high limit with something little lower than 165, because we don't want, just in case, we don't want to trip those dampers off. I'd rather the furnace trips off, and if it trips those dampers off, man, it's gonna build up a lot of positive pressure in there. I don't see an air proven switch. I don't remember if this has one. It should have one here. You got a manometer here, but it's just to this is just a magnehelic, but it's just to see your filter pressure. Yeah, there is no air proven switch. Oh, there I think there, no, there isn't one. This is, all right, yeah, there is an air proven switch. Oh, that's right, it's in here. So there is an air proven switch. But I think if you overpressurize the cabin, I'm not sure if that air proven switch would trip off or not. I don't think it will, actually. I think that's just to let you know that the blower's running. So it's just gonna be a normally closed switch when the blower's running. So anyhow, yeah, we gotta address that high limit there. So we'll figure out what's going on with that thing there. So anyhow, it's still running. It's gonna try to maintain that supply air. It's kind of cold outside, so but like I said, it has to have both calls. So once I pull my jumper off, it's gonna turn off. Here, let's see. Yeah, it's gonna turn off, but your heat call is still flashing because the DJM is getting a heat call still. So if I lower this down, and the heat call should turn off here in a second. Let me see. Come on. It takes a minute, but it will. It shut off earlier, so it'll do it again this time. So it looks like we're up and running, and we're doing what we're supposed to do. Right now, our return air is 58. So, like I said, as long as we're above 40, that's all. The job of this unit, this controller here, is just to protect the coil from freezing. Really, that's all it is, to preheat that air, protect that coil from freezing. So. Other than that, it's pretty simple wiring diagram on these engineered air units. And then and this is also the auxiliary high limit here, and that's for the preheat. So no more than 125 degrees on the preheat. And then you have a freeze step, which is going to shut the blower off in case the temperature drops below about 30, 36 is what they got it at. So all that does is go. All that does is go right across that coil, just like that there. And then there goes your preheat heaters right there as well too. All that does is drop across that coil right there. So other than that, yeah, there's nothing else to it. There's your evaporator coil right here. Then your air is coming down from the bottom, going up, and supplying out. And that's it. All right, guys, well, I hope you guys like it, and sorry for all the pauses on this one. I had to pause it a few times yesterday with the fire alarm going off and all that, but kind of out of my control, but just stuff we come across in the field here. So I'm trying to record as much as I can when I can. I try to kind of stay away from recording in front of the customers and things like that, though. But other than that, I try to record as much as I can. If you guys like and subscribe, start making more videos. Just let me know what you guys want to see. Let me know if you guys like it, if you don't. If you guys have any comments, negative, positive, whatever, it don't bother me any. I'll take all criticism there. So anyhow, I appreciate it, guys. See that DJM finally turned off as well too right there, so it's no longer blinking. But anyhow, I appreciate it, guys. You guys enjoy, have a good one, and thanks for watching the video.